Alright, so we're on the fourth video here of the review. On number 22, we're supposed to find the rational zeros, possible rational zeros here. That's where we do our P's and Q's. And so we know P's are factors of the constant term 12. And our factors of Q, that would be, in this case, the leading coefficient, which is 1. And so let's go ahead and write the factors of 12. Of course, 12 is divisible by 1 and 2, also by 3 and 4. Of course, 5 doesn't work, but 6 does. Not 7, not 8, not 9, not 10, not 11, but 12. And excuse me, one of the things we've learned is you can pair these up and see if you're missing anything. Hopefully you're not missing a whole pair, but otherwise you should catch anything you're missing. So that's our numerator, and then in the denominator the factors of 1 are just 1. And so we're going to take each of the factors of P and put them over 1. Well, that's just going to be the factors in the numerator there. I'm going to go ahead and put the plus or minus out front in parentheses or braces, and just to indicate that we're looking at the positive and negative of each number here. So one of these answers, I should say one of these zeros, we should be able to find to work. And once we do, we have to, well, synthetic division will show that it's a 0. So if you try 1, it turns out it actually works. Now, for some of you, depending on what we did with this class, you may have gotten your first 0 from the calculator, but you've got to show that it's a 0. So, excuse me, we're going to take the coefficients of our polynomial. So we have a 1x cubed. Notice there's no x squared term, so we'll put a 0 there. And then a minus 13 for the x term, and then the constant. So you want to make sure that each power of x is represented, and put in a 0 if you're missing any of the powers of x. And so now we want to drop the 1, and then we know that we want to multiply, then add, multiply, then add. So here we multiply, we get 1. We always add in the columns. Here we're going to get 0 plus 1 is 1. And then 1 times 1 is 1. When we add negative 13 and 1, we get negative 12. Negative 12 times 1 is negative 12. And when we add, we get 0. And so, sure enough, this is a 0. If you find f of 1, it does equal 0. That's what it means to be a 0. And so, the big thing, though, is we know that 1's a 0, but we can find the other zeros using the answer that we got here. We can write the function f of x as, again, if 1 is a 0, then we know x minus 1 is a factor. And then the other factor comes from our answer. Now, our term, or I should say our leading term there is x cubed, so we know we're going to decrease that by 1. This will be a 1x squared plus a 1x minus 12. This number should always be your constant, and sure enough it is. And then if you look at what we have here, x squared plus x minus 12, we can factor that using the AC method. And so I need two numbers that multiply to negative 12 and add to 1. We can get 3 and 4 to work here. Let's see, we need opposite signs, and we want the smaller number to be negative so that when we add, we get a positive 1. And so negative 3 times 4 is negative 12, and negative 3 plus 4 is 1. That's what's going to work here. And so when we factor, we get x minus 3 times x plus 4. Now, the complete factorization would be that there. But we were asked to find the remaining zeros. So we've got a 0 of 3 and negative 4 in addition to the one that we already got. Let's move on to 22. So the possible zeros, again, we're going to do our P's and Q's. The factors of P, or in this case 9, let's see, 1, 3, and 9 would work. The factors of 2, well, that would be 1 and 2. And so we're going to take each of the factors in the numerator and put those over 1. So that's just going to be 1, 3, and 9. And then we're going to put each of our factors in the numerator over 2. So 1 over 2 gives you 1/2. 3 over 2 gives you 3/2. And 9 over 2 gives you 9/2. We don't write any repeats anytime that we do this. So notice we have these 6 positive zeros and also negative, so a total of 12 possible rational zeros. Now when you start going through these, I would start with the positives. 1 doesn't work, but 3 does. Again, for some of you, if you have the calculator and we allowed you to use your calculator to get the first 0, you can do that. Turns out to be 3. And we expect to get 0 here when we do synthetic division. So drop the 2, we're going to multiply, we get 6. And when we add here, we get 5. Multiply, we get 15. When we add, we're going to get -3. Multiply, we get -9. And when we add, we get 0. And so again, we verified that x equals 3 is a 0. Which means x minus 3 is a factor of f of x. There's my 0, x equals 3. And then our answer is what we're going to be using to get the other factors, or other zeros. And so we need to factor 2x squared plus 5x minus 3. So here AC is going to be -6. And b is 5, and so we need two numbers that multiply to -6 and add to 5. The numbers that are going to work here are -1 and 6. Notice -1 times 6 is -6, and -1 plus 6 is 5. So when we split our b term, and we don't have a choice here, this is not a 1, and so we can't take any shortcuts here. We'll split our 5x into -1x plus 6x, and factor by grouping. We can factor out an x right there, times 2x minus 1. And when we factor here, we're expecting a 2x minus 1. And we need something times 2x to give us 6x. That would be 3. Notice 3 times -1 does give you the -3. All right, so our factorization here is a 2x minus 1 times x plus 3. So I'm going to go ahead and finish factoring down below. So you can see that -3 is another 0 besides the 3 that we already got. And if we set 2x minus 1 equal to 0, we'll get our other 0. It's going to be 1/2. All right, let's move on to 24. So here we're solving radical equations. The first two only have one radical. The thing we want to remember with those is we're going to end up squaring both sides. But before we do that, we have to make sure that the radical is isolated. The other thing to recall with radical equations is you always want to check your answers, because sometimes we get a value that won't work, and so we have to throw it out. So on this first one, we want to get rid of the 5 there by subtracting 5 on both sides. We get square root of x plus 2 is equal to 3. And then to get to the x, so we can solve for x, we're going to have to get rid of that radical. Of course, the opposite of taking a square root is squaring. And so we're going to square both sides. When you square a square root, you're going to get what's inside. So here we just get x plus 2. And of course, whatever we do to one side, we do to the other. We need to square 3, we get 9. Subtract 2 on both sides, and you get x equals 7. So let's go ahead and check this. So I plugged in 7 for x. We have 5 plus the square root of 9. Square root of 9 is 3. 5 plus 3 does equal 8. So it does check. All right, let's move on to B. We already have the radical isolated, so all we have to do is square each side. I'm going to rewrite it and square both sides. And so when we square the square root on the left there, we're going to get x plus 10. Now on the right side, we're going to have to multiply 2x minus 2's. So I'm going to go ahead and do that off to the side. We're going to FOIL here. We get x squared minus 2x. Another minus 2x, and then plus 4. And so we're going to end up with x squared minus 4x plus 4 there. And so that's going to go on the right side there. All right, so what we have here is a quadratic equation, and we need to get 0 on one side. So let's go ahead and subtract x on both sides and also 10. So on the left, we're going to get 0. And then we have x squared, a minus 4x, and a minus 1x is a minus 5x. And then 4 and negative 10 is negative 6. And then this is certainly something we should be able to factor during the AC method, or we would expect. And sure enough, 1 and 6 work here. We're going to need to make the 6 negative in order to make it work. So we end up with x plus 1 and x minus 6. So x is either negative 1 or 6. Now let's go ahead and plug in negative 1. The square root of negative 1 plus 10, that would be square root of 9, which is 3. Negative 1 minus 2 is not 3, it's negative 3, and so this does not check. If you try the 6, it does work, so let me go ahead and write that as our final answer. Alright, let's look at C. So now we have two radicals, and so in these problems we need a radical on each side, and then we're going to square both sides. And we're going to end up having to square both sides twice with this kind of problem. On letter C, let's see, let's go ahead and square each side. If we square the left side, we're going to get 3x plus 10. Now on the other side, we're going to have to FOIL that. That's two terms. Let's go ahead and write out two of those. And so we got, actually I'm going to go ahead and FOIL right here. So 3 times 3 is 9 with the first terms. The outer product is going to be 3 times the square root of x minus 1. The inner product is going to be the same, 3 times square root of x minus 1. And then now when we multiply a radical times itself, there's something we want to remember here. We have square root of x minus 1 times square root of x minus 1. We learned that if you multiply the square root of something times the square root of the same thing, we get the number inside. Why is that? Well, the square root of x times square root of x, isn't that really the square root of x squared? And again, those are opposites, and so if you have the square root of x and then you square it, you're going to get what's inside, which is x. And it could be anything. If I have a square root of 5x plus 12 times the square root of 5x plus 12, I'm going to get 5x plus 12. So in the problem we're doing, square root of x times x minus 1 times the square root of x minus 1 is just going to be x minus 1. And we did have a positive times a positive there, so it's plus x minus 1. All right, and then the other thing we want to talk about is how we combine like radicals. Let me rewrite this first, though. We have 3x plus 10 on the left. Notice 9 and a minus 1 is 8. So here's where we have like radicals. So here's an example I'm doing off to the left here. 2 square roots of 3 plus 5 square roots of 3. We add like radicals just like we do with like terms. The thing that makes these like radicals is they both are square roots and they both have a 3 under the radical. So not only do they have to both be square roots, they both have to have the same number under the radical to be like radicals. And in this case, we just add the 2 and 5 and we get 7 square roots of 3. It's just like when we add like terms, very similar. So if you look at the problem we're doing, we have 3 square root of x minus 1 plus 3 square root of x minus 1. These are like radicals, and we just add the numbers out front. We're going to get 6 times the square root of x minus 1. And then let's go ahead and bring that x down as well. Don't forget about the x. So now that we've FOILed and we've combined everything we could on the right, what we need to do now is get the radical by itself. So we're going to need to get rid of the 8, and we're going to need to get rid of the x. I'm going to do that in, I think I did it in, well, let's see. 3x, if we subtract x on both sides, that'll be 3x minus x, and we get 2x. If we subtract 8 on both sides, we'll get rid of the 8 on the right, and on the left, we'll have 10 minus 8, and so we get 2. So all I've done is subtracted x on both sides, and I subtracted 8 on both sides, so that I could get the radical by itself. I'm not showing that step just because I'm running out of space here. Now, in this is a challenging problem, I would just point out. Some of the things we're having to do here are a little bit different than some of the things we've run into on a more typical problem. All of these numbers are even. So to make things a little bit easier on us, I'm going to go ahead and divide both sides by 2. And so we get x plus 1 is equal to 3 times the square root of x minus 1. The other thing is, at this point, to get the radical by itself, I'd have to divide by 3. And I'd end up with 2 fractions on the left. Again, to keep things simpler, we can actually square things on both sides now as they are, and that's not going to be a problem. It makes things a little bit easier. So let's go ahead and square both sides. Of course, on the left, we're going to have to multiply 2x plus 1s. So we're going to get x squared plus 2x plus 1 when we do that. All we're doing is foiling there. And then on the other side, we're going to multiply 3 square root of x minus 1 times itself. So this is all multiplication. We can multiply the 3's together and we get 9. And we learned that the square root of x minus 1 times the square root of x minus 1 is just x minus 1. Now keep in mind we have to multiply 9 times the whole x minus 1, so we need to put parentheses around that. And so we're going to end up with 9x minus 9 on the right side. So now we have a quadratic equation. We're going to want to get 0 on one side and everything else on the other. So I'm going to subtract 9x and add 9 to accomplish that. So we've got x squared minus 7x plus 10 equals 0. Let's go ahead and factor that. It should factor using the AC method. You'll find that it's x minus 2 times x minus 5. And so we get 2 and 5. And in fact, both of those answers work. You can verify that for yourself. Again, I'm trying to save some space, so I won't do that, but it's not too hard to check those. All right, let's look at D. So here we have 2 radicals, but they're not on opposite sides. So we're going to want to subtract square root of x on both sides. We could also subtract the square root of x plus 7 on both sides. It's just kind of personal preference. I'm going to subtract the square root of x. And so on the left, I'm left with the square root of x plus 7. And on the right, I have 7 minus the square root of x. So I'm going to square both sides. On the left, we're just going to get x plus 7. On the right, we're going to have to FOIL that. So 7 times 7, we're going to get 49. We've got a 7 times a minus square root of x. That'll be minus 7 square root of x. Notice I can't multiply those together because one's a number and one's a radical. If I had square root of 7 times square root of x, I would have square root of 7x. But in this case, I'd put the 7 out front. Same thing with the inner product. You're also going to get a minus 7 square root of x. And then we have a negative times a negative, so we're going to get a plus. And we know square root of x times square root of x is just x. And so we do have 2 like radicals there. Notice they both are square roots of x. And so we're just going to add the negative 7 and the negative 7, and we'll get 49 minus 14 square root of x. And then don't forget the plus x there. And so that's what we have on the right side. So once again, we want to get the radical by itself now that we've simplified everything. Notice if we subtract x on both sides, that works out kind of nice. We got rid of the x's. And we need to subtract 49 on both sides to get rid of that 49. We'll get negative 42 is equal to negative 14 times the square root of x. And so now I'm not quite there. I need to get rid of that negative 14 to get the radical by itself. So we'll divide both sides by negative 14. And so we're going to get square root of x is equal to 3. Well, finally, we can square both sides, and we're going to get x is equal to 9. And I'll go ahead and check this one with you guys. The square root of 9 plus 7 plus the square root of 9 equals 7. Notice the square root of 9 plus 7, that's square root of 16, which is 4. And square root of 9 is 3. And 4 plus 3 does equal 7, and so you can see that it works. All right, let's move on to the next page. Actually, it looks like my time is up here. I'm going to go ahead and stop right here.